We can do parametric curves with Desmos too. These instructions are in the homework, but I want to demonstrate for you what they do here. So let's go to Desmos, and we've got cosine 3t, sine 1t, and then it says, oh, do you want t to be a slider between, not a slider, do you want t to range as a parametric parameter between 0 and 1? 1 isn't the most useful upper end for trig functions, so something like 2 pi might be better, and we get an interesting thing there. So that's just typing in plain numbers here. We can also put in parameters. We could say cosine AT and sine BT and make sliders out of all of it. Let's show this a little better. And let's have t go from 0 to 2 pi. And then we can adjust the sliders. See interesting things happening there. Let's set that back to 1. And what if we adjust the B slider? We get same interesting things happening, but in the other direction. Maybe not a surprise there. Here's something interesting. What if I set A to 1 and B to 1? I get the unit circle. That's cosine of t, comma sine of t. Not a big surprise. What if I set B to -1? I seem to also get the unit circle, but it turns out there's a difference there, and we'll talk about that in the next graph. Better than just saying cosine and sine in parentheses to say here's the parametric curve you want, you can say only plot it when the t parameter is less than some cutoff I'm going to set. I'm going to use capital T, but it could be any variable letter you want. So I'm going to put in here like curly brace little t less than big T, close curly brace, and add a big T slider. And then I can change big T so it will draw more and more or less and less of the curve. I'm going to have this go from 0 to 2 pi. And I'm going to change B to be 1 again. So now if I increase T, then you see I'm tracing out the unit circle in kind of the positive radian direction, like I'm going 0 radians. Here's basically 0 radians, here's pi over 2 radians, here's pi radians, here's 3 pi over 2 radians, here's 2 pi. But if I go back here and set B to -1, and then start increasing T, then I'm tracing out the unit circle in the backwards direction. So I get the same curve in the plane, the same set of points, but I trace it out in a different way as my parameter varies. So that's an important thing about parametric curves. You can get the same set of points in the plane, but trace it out in different ways. I could even do like cosine AT squared and BT squared, and I still get the unit circle, but as t increases, I get the unit circle starting out slowly and then going quickly. So I actually change the speed as I go along. So another important thing is a lot of times in Desmos, instead of typing functions in directly like this, it's better to define them, and then you can use them later in more than one place without having to retype like cosine BT or something. So let's go do that. That's a general principle in computer programming anyway, right? That you should define a function once and then use it in many places. So I'm going to say f of t equals cosine AT and g of t equals sine BT. And then instead of typing those here, I can just say f of t and g of t. And then that's graphing the two functions with time as the x-axis and g and f on the y-axis, which I'm not actually all that interested in for this plot, so I'm going to hide those. And then I can do this. The nice thing about this is that I can also say plot f at big T, g at big T, and that puts a point there. I can even label it with its current value. So that way I'm defining things once, f and g, then using them more than once without having to retype. One more interesting thing, here I really have to use the letter T to get this to work properly as parametric stuff. The letter I use up here to define it doesn't have to be T. It could be X, which would be really confusing. It could be, what's another letter of the alphabet? How about Z? So I could define basically whatever you type here, what's another letter of the alphabet? It doesn't even have to be the same or different. So whatever letter you type here, it will use over here as if it was kind of X or T as usual. So those letters don't have to be T's, but this letter right here and this one here, those do have to be T's. So that's a quick intro to Desmos and graphing parametric equations. Now let's kind of put our A sliders in motion and B sliders in motion and see all the kind of interesting figures we get. These are all called Lissajous figures. I'm not sure how you pronounce that, but I can type it here at least. It's a French word. I think it's named after the apparent inventor of them. So setting integer parameters for A and B, like A equals 3, B equals 5. Whoop, let's try that again. Gives us this interesting trace where we go kind of up and down 5 times and left and right 3 times, or vice versa. We'd have to think about that. So that's a nice way to make some interesting patterns in with parametric curves.